At this very moment, two spacecraft billions of kilometers from Earth are continuing one of the greatest scientific missions in history. Voyager 1 and Voyager 2 have been operating for nearly 50 years, making them the longest-lived spacecraft ever to explore the outer solar system. Their electrical power is gradually declining, and NASA continues to shut down scientific instruments one by one to keep the mission alive for as long as possible. Eventually, the spacecraft will no longer have enough power to operate their scientific instruments and communicate with Earth, bringing one of the longest-running and most successful planetary exploration missions ever undertaken to an end. But even after nearly half a century, the Voyagers continue to answer scientific questions that no other spacecraft can. What are they still sending us today? Why are these final transmissions so important? And what have these spacecraft taught us about the boundary between our solar system and interstellar space? Let's find out. Voyager 1 and Voyager 2 were launched in 1977 as part of NASA's Voyager program to explore the giant planets of the solar system. Their mission took advantage of a rare alignment of Jupiter, Saturn, Uranus, and Neptune that occurs only about once every 176 years. This alignment made it possible to use gravity assists, allowing each spacecraft to gain speed by passing close to a planet and using its gravity to change direction without consuming significant amounts of fuel. Without this rare planetary alignment, visiting all 4 giant planets with a single mission would have been impossible using the technology available at the time. Although Voyager 1 was launched after Voyager 2, it was placed on a faster trajectory, allowing it to reach Jupiter and Saturn first. Voyager 1 studied Jupiter and Saturn before heading out of the plane of the solar system. Voyager 2 followed a different path, allowing it to continue its historic journey to Uranus in 1986 and Neptune in 1989. To this day, Voyager 2 remains the only spacecraft ever to visit either of those planets. The Voyager mission transformed scientists' understanding of the outer solar system. At Jupiter, the spacecraft observed enormous storms, active volcanoes on the moon Io, and faint planetary rings that had never been seen before. At Saturn, they revealed complex structures within the planet's rings and collected detailed observations of its largest moon, Titan. Voyager 2 later discovered new moons around Uranus and Neptune, measured their unusual magnetic fields, and provided humanity with its first close-up views of these distant worlds. Many of these discoveries fundamentally changed our understanding of how giant planets and their moons formed and evolved. After completing their planetary missions, both spacecraft continued traveling away from the Sun. Their new objective became something no spacecraft had ever accomplished before: reaching interstellar space. Scientists expected this journey to take decades, and they were right. In 2012, Voyager 1 crossed the heliopause, the boundary where the influence of the solar wind is no longer dominant and the local interstellar medium becomes the surrounding environment. Voyager 2 crossed the same boundary in 2018, becoming the second spacecraft in history to enter interstellar space. These crossings provided the first direct measurements of conditions beyond the heliosphere, something that had previously existed only in scientific models. Today, both Voyagers continue to return scientific data from a region of space that no previous spacecraft had ever explored. Although many of their scientific instruments have already been turned off to conserve power, the remaining instruments continue to measure the environment surrounding the spacecraft. They collect information about the density and temperature of interstellar plasma, the intensity of cosmic rays, the strength and direction of the interstellar magnetic field, and energetic charged particles traveling through interstellar space. These measurements help scientists understand how the heliosphere, the enormous bubble created by the solar wind, interacts with the local interstellar medium. Because Voyager 1 and Voyager 2 crossed the heliopause at different locations and 6 years apart, scientists can compare their measurements to better understand how conditions vary around the edge of the heliosphere. The data also helps researchers improve models of how our solar system interacts with the rest of the Milky Way. Communicating with the Voyagers is an extraordinary engineering challenge. The spacecraft transmit with a radio transmitter that produces only about 20 watts of power, less than many household light bulbs. Yet those faint signals can still be detected on Earth thanks to NASA's Deep Space Network, a worldwide system of giant radio antennas located in California, Spain, and Australia. These three complexes are spaced roughly 120 degrees apart around Earth, allowing at least one station to communicate with distant spacecraft at almost any time as our planet rotates. Even though the radio signal travels at the speed of light, it currently takes about 24 hours for a transmission from Voyager 1 to reach Earth. Any command sent from Earth requires about the same amount of time to reach the spacecraft. Because of this delay, engineers cannot control the spacecraft in real time. Every command must be carefully planned, transmitted, and then verified days later after a response is received. The Voyagers are powered by radioisotope thermoelectric generators, or RTGs, fueled by plutonium-238. Unlike solar panels, RTGs produce electricity from the heat released during the natural radioactive decay of plutonium. This power source was essential because sunlight is far too weak in the outer solar system to provide enough energy for the spacecraft. As the plutonium slowly decays, the generators produce approximately 4 watts less electrical power each year. To keep the spacecraft operating for as long as possible, NASA gradually shuts down scientific instruments and other non-essential systems. In recent years, engineers have also turned off heaters and backup systems that were originally intended to protect the spacecraft. These decisions allow the remaining electrical power to be reserved for critical systems, including the onboard computer, the radio transmitter, and the scientific instruments that are still operating. The fact that both spacecraft continue functioning after nearly 5 decades is considered one of the greatest engineering achievements in the history of space exploration. By modern standards, the Voyagers are extremely simple computers. Their onboard computers were designed in the early 1970s and have only a tiny fraction of the computing power found in today's smartphones. Instead of relying on powerful processors, the spacecraft were designed to be exceptionally reliable. Most of their commands are stored in memory and executed automatically, allowing the spacecraft to operate for long periods without direct intervention from Earth. NASA engineers still communicate with computers that were designed more than 50 years ago, and in some cases they continue using programming techniques developed before the first personal computers even existed. Keeping these aging systems operating across billions of kilometers of space has required decades of creative engineering and careful planning. The Voyager mission is gradually approaching its conclusion. As the spacecraft continue to lose electrical power, NASA will keep shutting down their remaining scientific instruments one at a time. Eventually, there will no longer be enough power to operate both the scientific instruments and the radio transmitter. When that happens, the spacecraft will stop returning data to Earth, marking the end of their scientific mission. Even then, however, their journey will continue. With no engines to slow them down and almost no matter in interstellar space to stop them, both spacecraft will continue orbiting the center of the Milky Way for millions, likely billions, of years. Each Voyager carries one of the most remarkable artifacts ever sent into space: the Golden Record. The record was created by a team led by astronomer Carl Sagan and was intended as a symbolic message from humanity. It contains 115 encoded images, sounds of nature, spoken greetings in 55 languages, music from many cultures, and recordings ranging from birdsong and thunder to human laughter and a heartbeat. It also includes instructions describing how the record can be played, along with scientific information intended to help explain where it came from. The chances of another civilization ever finding the Golden Record are considered extremely small. Even so, it remains a unique time capsule, a snapshot of life on Earth in the 1970s, preserved aboard 2 spacecraft now traveling between the stars. Although their scientific mission will eventually end, the Voyagers themselves will continue traveling through our galaxy. In about 40,000 years, Voyager 1 is expected to pass within approximately 1.6 light-years of the star Gliese 445 in the constellation Camelopardalis. Around the same time, Voyager 2 will pass about 1.7 light-years from the star Ross 248 in the constellation Andromeda. Neither spacecraft is expected to enter another planetary system or collide with a star. Instead, they will continue silently orbiting the Milky Way long after Earth, its continents, and even the night sky have changed beyond recognition. Voyager 1 and Voyager 2 were built to explore the outer planets of our solar system. Instead, they became the first spacecraft to reach interstellar space, transforming our understanding of the solar system and its boundary with the rest of our galaxy. Nearly 50 years after launch, they are still returning scientific data from farther away than any spacecraft before them. Every transmission received today extends one of the most extraordinary scientific missions ever undertaken. Eventually, the signals will stop and the spacecraft will fall silent. But their discoveries will continue to shape space science for generations, while the Voyagers themselves carry humanity's story across the Milky Way for millions, perhaps billions, of years.